Greetings, students. This is the first set of notes about maps. It's called Maps Notes Part 1. What is a map? A map is a bird's eye view model of an area. Maps have been used throughout history to accurately navigate from one place to another. The science of map making is called cartography. What we see on the left side here is not a very detailed map. Um, it's kind of like a fun map, but a map nonetheless. It shows the accurate locations um, of some cities, and it's got some interesting activities and resources in attractions in various areas of the state of Delaware. You couldn't use this map to navigate through Delaware, but you could get some information from it nonetheless. Here is a super accurate computer rendering of the Earth as a sphere from Google Earth. And one of the challenges of map making is to take this three-dimensional object that is the Earth sphere and put it on a two-dimensional piece of paper like so. What we have here is the Mercator projection, which is what people are used to looking at in school. It shows all of the continents, but what it does is it has to fudge the sizes a little bit in order to take that three-dimensional sphere and put it onto a flat page. Countries like Greenland and Canada and the continent of Antarctica are shown as way bigger on this map than they are in relation to other places. Greenland is nowhere near as large as Africa, but on this map, Greenland looks like it's as big as Africa. And we'll talk a little more about that later. Here's a smaller map that would be a useful map for getting around Richmond, perhaps. Not extremely detailed, but it has the names of some areas, and it also has highway exits. But this map wouldn't be super useful because it's missing some things that are important, like a scale and a key. All maps should have a scale. A scale is usually shown in the margin of a map, and the scale is the ratio of distance on a map to the actual distance on the ground. So on the one on the right, you see centimeters on the map. 1 centimeter on the map is equal to half a kilometer on the ground. So the ratio of distance on the map to actual distance on the ground is called the scale, and it needs to be consistent throughout the map. On a map of the world, 1 centimeter might equal 100 kilometers. And that would be shown as 1 to, looks like 100 million. But on a map of your neighborhood, 1 centimeter on a map might equal 1 meter on the ground, and that would be 1 to 100. Maps should also have a key. A key tells the meaning of symbols, colors, and lines. Every map should also have a compass that indicates the cardinal directions, north, south, east, and west. North is towards the North Pole, south is towards the South Pole. When one is facing north, west is to the left and east is to the right. There are also directions between the cardinal directions, like northwest, northeast, southwest, and southeast. So if you list two cardinal directions together, that's between the cardinal directions. You can't have north-south, but you can have northwest or northeast. You can't have west-east, but you can have southwest or southeast or northwest or northeast. And you can get even more specific with 3 letters. Between northwest and north is north-northwest. And between south and southeast is south-southeast. So you might encounter questions like this on the test that shows you a map of an area, maybe Virginia. and it wants to know what direction is Richmond from Fredericksburg. So you have to be careful how this is worded. From Fredericksburg, Richmond is south. What direction is Blacksburg from Roanoke? From Roanoke, Blacksburg is to the west. Map technology has improved since people have been making maps for thousands of years. Over human history, maps have become more and more accurate. Today we use satellites and GPS, and that stands for Global Positioning Systems, to make extremely accurate computer maps. This is an older map, which is really not very useful, even in its time. This is a slightly more accurate map by a Venetian monk, Fra Mauro, between 1457 and 1459, and it contains Europe and Asia and parts of Africa, but it's missing what was considered the New World as far as this monk was concerned. And you can see that it had some accurate things, like some of the shapes, like the shape of the Mediterranean is pretty accurate. But the further away you get from Europe, Africa is going to be a little wonky, and East Asia is going to be not quite so accurate. So we learned about triangulation in the plate tectonics unit when we were talking about earthquakes. Triangulation also works for satellites. You need 3 satellites to pinpoint an exact location on the surface of the Earth. That is also called triangulation. Latitude and longitude is like a grid on top of a map or superimposed over the globe. And latitude and longitude can be used without GPS. It's like graph paper, and it's used to determine exact locations on the surface of the Earth. So here you see a map of the world, and you see the grid is superimposed over the map. Latitude and longitude are measured in degrees, minutes, and seconds. There are 60 minutes in a degree and 60 seconds in a minute, and they're used like coordinates on a grid. Latitude is always given first with a designation of north or south, and longitude is always given second with a designation of east or west. The coordinates of Richmond, Virginia are 37 degrees north, 32 minutes and 28 seconds, and 77 degrees west, 26 minutes and 5 seconds. It's very important to designate north and west here, because if you looked for the same location south and east, you'd be in the Indian Ocean rather than in Richmond, because we are in the northern hemisphere and the western hemisphere. So west is west of the prime meridian, that's that vertical line that crosses through Europe and Africa, and north is north of the equator. Some latitudes to know. 0 degrees latitude is the equator, 90 degrees north is the North Pole, 90 degrees south is the South Pole. 23.5 degrees north is the Tropic of Cancer, 23.5 degrees south is the Tropic of Capricorn. Between those is the equator, and the whole area between the tropics is tropical. And then above 66 degrees north is the Arctic Circle. Above that is kind of the polar region, and 66 degrees south is the Antarctic Circle, and below that is also the southern polar region. Longitudes to know, I've just got 2 for you. 0 degrees longitude is the prime meridian, and then 180 degrees longitude is the international date line. So longitude goes from 0 to 180. Latitude only goes from 0 to 90. So a little more about latitude lines. Latitude lines are circles. They don't touch one another. They're running parallel to one another. And it measures distance either north or south of the equator. When I'm trying to figure out which is which, I think of latitude as a ladder, and you climb up and down. north or south from the equator. Latitude lines are sometimes called parallels because they're parallel to one another. And the amount of distance between latitude lines is always the same. It's 111 kilometers each degree. And I already told you about the Tropic of Cancer and the Tropic of Capricorn. Longitude lines are called meridians, and they run perpendicular to the equator, and they measure distance east or west from the prime meridian, which is 0 degrees longitude. The prime meridian runs through the North Pole, the South Pole, and a town called Greenwich, England. Longitude lines are not parallel to one another. All longitude lines run through the North and South Pole, so as you get closer to one of the poles, the longitude lines are converging. They're getting closer together. Therefore, the amount of distance covered between the lines of longitude can change based on your location. If you're closer to the poles, that distance is very short. If you're closer to the equator, that distance is bigger. And you can see here the meridians. They're the vertical lines. They run perpendicular to the equator, measuring distance east or west of the prime meridian. But at the poles, they touch. It'll be important to be able to locate the prime meridian and equator on a globe or a world map. The equator, like all lines of latitude, runs all the way around the globe, but the prime meridian only spans half of the globe, and all lines of longitude only go from the North Pole to the South Pole. On the opposite side of the prime meridian is called the international dateline. The international dateline is 180 degrees longitude. And you can see it's kind of crooked because on one side of it, it's a different day than the other side as the Earth spins. And so countries want to be on one day or the other. So we'll be doing this in class, but you're going to be asked to find the coordinates of each letter. And I'll just do a couple here right now, starting with C. It's easy to find. So C is north of the equator. So the first thing you say is the latitude. And if you locate the equator, that's 0 degrees, the horizontal line. And then you climb north, it's 60 degrees north, the line that C sits on. And then C is going to be east of the prime meridian. The prime meridian is 0 degrees longitude, so it runs through Europe and Africa in the center vertically. And you count over from the prime meridian to 60 degrees east longitude. So the coordinates of the location C is 60 degrees north, 60 degrees east. So one more thing about maps, the simple concept of maps is complicated by the natural curvature of the Earth. That's what I was talking about at the beginning of the notes. You have a globe, a sphere that is the Earth, and you want to put that on a flat page, and you have to distort the shapes of lands and bodies of water in order to make that fit. You've got a three-dimensional sphere, and you want to translate it into a two-dimensional map. Over time, people have used different projections to map the entire globe with varying levels of accuracy. We're used to looking at the Mercator projection. That's the most commonly used world map projection, but it distorts areas near the poles. There's many other examples of world map projections that distort differently. So this is the Mercator projection, but I just show you this as a kind of what's wrong with this picture. A very Americentric map. We've got America in the center, and we've chopped Asia in half in order to show the whole globe. Usually these days you'll see North and South America on the left and then all of Eurasia on the right. But some people are very self-important, so they put their own country in the center. So here's the Mercator projection that I showed you earlier. Canada, Greenland, northern Russia, and Antarctica are all really distorted. They're shown as way bigger than they actually are. And by the way, there's no reason why north is up in outer space. So in a different timeline, we might look at the map this way. This is called the McBride-Thomas projection, which actually slices the map to show the more global shape, and this has more accurate continent sizes. You can see Greenland's actually much smaller, and Africa is proportionally shown as the biggest, one of the biggest land masses. This is called the Gall-Peters projection. This is one of the more accurate ones. It looks funny, but it's more accurate than the Mercator projection as far as the relative sizes of the continents. Here's some more fun locating coordinates of latitude and longitude. This will be a separate assignment. You don't have to do this right now. So here is the notes for maps part 1 all together on one slide. You are welcome to type it or handwrite it. You can pause it here and catch up. You can rewatch the video. You can use my fill in the blank notes as well, and this goes in your digital science notebook.